Let's just leave it like that. Alright then, we're going to continue our journey on solving quadratics, but this time we're going to be looking at completing the square. Completing the square is this funny situation where you kind of make it into this square. Actually, I'll show you in a second with a bit of a visual and I'll get this sorted. Right then, so we're back on to solving quadratics, and what that means is same as last time. When your quadratic is equal to 0, what values of x make it work? Now completing the square is when, let me just write a quick example of what one is. This is an example of completing the square. We've got our quadratic, x squared minus 8x plus 3 is equal to x minus 4 all squared minus 13. Actually, it's equivalent to, because it's always identical to. I can't stop laughing for some reason. So the reason why it's called completing the square is because we've got this little bit here and we've put it into a squared term. We've put this minus 13 on it. It's called completing the square because of that. Now there's a little bit of a visual representation of this that I can get from Wikipedia. So I'm going to put that here, then you can watch that for a moment and then hopefully you'll understand it a little bit better. I might fast forward it. Right, hopefully you got a bit of a better understanding as why it's called completing the square from that video. If not, it doesn't matter. What's really important is that you can write some quadratic in the form of this squared bit and then this little correction on the end. Now I'm going to write what it is here and then we're just going to talk about that equating the coefficients that I mentioned earlier. So this is the definition of completing the square. You take your quadratic and you put it in some form like this, where you've got a times x plus p, that's your squared bit, and it's got this little correction bit on the end. What we can do with that is that we can expand that and then actually see what we're meant to do. So let's expand this. So now we've expanded it, we can actually do what we did previously, which is equating coefficients. Let's have a look at the coefficient of x squared. Well, we find that that a is actually the same as that a because that's all the ways that we can make x squared. How about the x coefficient? This b must be equal to 2ap. Now the c, the constant at the end, is that ap squared plus q. What this leaves us with is three little situations. We've got the trivial one, a is a, then we've got b is equal to 2ap, and then that last one of c is equal to that last bit. So what do you do with that? Well, let's do this in black pen. So what we've done here is we've got a is a, that's fine. Then we've got b is equal to 2ap. If we rearrange that, then we get p is equal to b over 2a. Then we've got c equals ap squared plus q. If we use our value of p equals b over 2a, substitute that in, rearrange to get q, then you get q equals c minus b squared over 4a. These are quite important, so I'm going to put a little red pen around them. Nice. What they mean is that if you were given a quadratic like this, or like this, you can just look at it and be like, well, a is a, then our b is equal, no, our p, sorry, the p, which is in here, is equal to b over 2a. So here, b is minus 8, a is 1, so we just divide it by 2, get minus 4. That's where that came from. And then our q is c minus b squared over 4a. So q at the end, we have to take our c, which is 3 here, then minus b squared, so minus minus, so it's 64 divided by 4 times 1, so it's 64 divided by 4, which is 16. And then we do our, so it's minus 16 plus 3 minus 13. Yes, that's it. That's completing the square. However, we've not actually talked about solving equations yet, and we need to do some examples. So let's get cracking, do some more examples, and talk about actually solving them and what it means to solve. But again, like last time though, there's two situations. One when a equals 1, that's easy, and 2, which is when a is not equal to 1. Let's just get cracking anyway. Right, here's our little question. We've got solve this, it's equal to 0. Our first step is to write it in completing the square form. So what we're going to do is, we're going to follow this rule, but we're going to make a shortcut. Because a is equal to 1, we're just going to write, so x, we're going to do our brackets, x squared, our a is 1, so they'll just leave that. Then we're just going to do half of b here. Half of that is 5. Then we have to do what's on the outside. If we squared all this out, we'd get an extra 25. We'd get 25 at the end, you know, because we'd get x squared, then we get 2 lots of this times x, so that'd be 10x. Then we get an extra 25, so we minus 25. But then we need this plus 25 from before. All right, sweet. And that is equal to 0. Obviously this cancels with that. And we're left with easy. If we rearrange that, then all we're going to get is we square root 0 minus a 5. X is minus 5. One solution here. Isn't that good? I think it's pretty sound. Let's do another question. This is question 2. I've just noticed actually that I did this answer in black pen, which I shouldn't really do because it looks confusing. So I'm going to go back to blue pen. We've got a different situation here. Now we've got a is equal to 2. And I thought I'd just jump straight into a equals 2 because we don't want to dilly-dally with this all day. We're doing A-level after all. So how do we do this differently? Well, let's just compare to this. We want our x bracket squared because that's what completing the square is. Then this bit on the front is just going to be 2. Easy enough. Now what about this b here? Well, let's have a look at this. This is equal to that, so it's b over 2a. So we've got b is 4 plus 4 over 2 lots of a, which is 2 times 2, which is actually 4 over 4, so it's just going to be 1. But let's just keep it like this for now. Then we've got our c minus, so it's plus, well, it's plus c, but this is minus 3. So let's just do minus 3. Then we need to add on this bit, which would be squared. b squared over 4a. So that would be, yeah, we're left with this. 4 squared over 4 times 2. Hopefully that's right. I'm pretty sure it's right. So let's just keep going. We'll tidy this up a bit. That should be a minus. This should be a minus because it's minus b squared over 4a. So we've got b squared over 4a. And that's b over 2a. Yeah. Then we get 4 squared over 4, so that's 18, 2. Nice one. This is where we are. I feel this is a bit of a funny one, so I'm just going to take a moment to check it. The way that you can check it is just expand it all out and see if it works. Let's just do that. Look at that. it works. So we're back at 2x squared plus 4x minus 3. So it does work. Let's just get rid of that. Now I just want to quickly say, right, if you were doing this in an exam and you forget these little bits here, what I would do is probably just write this and equate the coefficients again. Just a quick reminder, write this out, square it, expand it, and then equate the coefficients again. I must admit, I never remember that. I just remember to equate the coefficients. It's easy as that. But it's whatever works for you. Let's continue. This is equal to 0. What we're going to do then, simple rearranging. We've square rooted, so when we square root, we need to do the plus or minus now. We're doing a level. And that's your answer. We've got x is equal to minus 1 plus or minus root 5 over 2. We can't simplify that third because 5's a prime and 2's a prime. We could write root 3. 5's not a prime. Yeah, it is. What's wrong with you? But anyway, because we've got a plus or minus, we've got two solutions there. So that's one solution, that's 2. What was different to get 2 solutions and 1 solution? Yeah, let's do one more example. This is our last example, sort of. You'll see. X squared minus 4x plus 7 equals 0. We're going to get cracking on this straight away. We're going to just, a is equal to 1, so we can go the easy way. Half of b minus 2, all that squared, plus that 7 from before. If we squared this out, we get minus 2 squared, which is 4. So we get an extra 4, so we might have to minus that 4 off. And that equals 0. Okay, so we've got this. Let's simplify that a bit. Okay, so x minus 2 squared plus 3 equals 0. Let's rearrange that. We'll minus the 3 off onto the other side. And then we'll do a square root. Plus or minus because it's, you know, A level. Square root of minus 3. There's a problem here already. If you put into your calculator square root of minus 3, it's going to say that beautiful thing of math error. What does math error mean? It means you can't do a square root of a negative number. Not with real numbers that you encounter in A-level maths. You actually need an entire new set of mathematics called complex numbers. So we get a problem here. I'm going to write it in a little sentence. See this? Square root of minus 3 is not a real number. That's what that means. It's not a member of the reals. So there is no real solution to the quadratic. There is a complex solution, but in A-level, we don't care about that. All we're going to say is that if this is square root of a negative, there's no solution. So we stop here. We have that little point. If you get the square root of a negative number, then there's no solutions. That is so important. I'm going to red box it. But let's go back here. Here we had 2 solutions. Here we had 1. The reason why there was 1 here is because it was the square root of 0. So, square root of 0 means that there's 1 solution. This one down here, square root of positive, 2 solutions. This board wobbles so much, I think I might get a blackboard. There we go, that's our third and final point. I've left a big gap here because we're going to do one more thing. We're going to just solve this here, right? Looking at this, you can see that we've got a minus number here, so if we move it over, it's going to be positive, so we can square root that. So it's going to have 2 solutions. So let's just do number 4. So many pens. Move it over, square root, then add 4, so that's it. You've got 2 solutions right there. When you do this though, all the examples I've had is you've only had rationals. No, sorry, irrationals. These surds cannot be simplified into a fraction. It's not always the case. It's just, I don't see the point of doing examples here, which we could have easily factorized. Because if you get, like if your answer here was 2 and 4, you could have factorized it. All these cannot be factorized by normal methods, that is. We have to do completing the square. See here? This 3, 2 numbers that multiply by 3, 1 and 3. Does 1 and 3, or -1 and -3 add to get -8? No. So in the last video when we said that some things can't be factorized, it doesn't mean they can't be solved. We have to use a different method, and that is completing the square. If you're short on time, you can actually, instead of using completing the square, use the quadratic formula, which we actually saw in video like 2 or 3, proof by deduction, and that's the end, where we proved it by completing the square on a generic quadratic. So the next video is where we're going to look at the quadratic formula and how to actually use it in terms of this. Have I covered everything? Yeah. I certainly have. Completing the square is putting a quadratic in that form. You do it through those. If it's the square root of 0 at the end, 1 solution. Square root of a positive number, 2 solutions. Square root of a negative, no solutions. You can't solve it. Just put them down somewhere. I think I need some water whilst I do this.